All right, so what remains is we need to talk about, instead of just one single value, but accumulation of values. And so we're going to extend this question to say, what's the probability that it's going to take more than 5 shots? All right, what's the probability it's going to take more than 5 shots to make the first three-pointer? And so in order to do this, what we have to assume is that we are going, what does that mean? If it's going to take more than 5, that means that the first 5 shots have been what? Have been misses, right? So we're going to come out here. We know that the probability of a make is 0.38. The probability of a miss is how much? 0.62, right? 1 minus 0.38. And so it's very straightforward here. We would say, well, the probability that these 5 shots are all going to be misses are going to be 0.62 times 0.62 times 0.62, right? 5 times. And so that's the specific application. Let's do that. What's 0.62 to the 5th? All right. And so it's almost 0.1. And so this tells us, let's say that we're like an NBA person covering the games. If you've got a shooter that hits 38% of their three-pointers, and then they go into game and they are just what they call, they're ice cold. They've missed, right, 4 shots or 5 shots in a row. So they missed 5 shots in a row. What's the probability, or how likely is that? Well, about 1 out of every 10 games that's going to happen. So if you're playing 80 games in a season, they're going to, it's very normal for them to have games where they miss 5 shots in a row, etc. Okay, so let's look at this specifically. How this works specifically, and this is kind of your final thing, the probability that x is going to be greater than some number n. Well, what did we do? We took 1 minus p, and this is basically the probability of failure, right? It's the probability that all of those first trials are going to be failure, and we took it to the power n because we wanted to say it's going to take n, that's the number of times that's going to take more than, and that means all of those are going to be failures, and this 1 minus p is the probability of failing. And so we should be able to use that to calculate. If we want to find out the probability that's going to take less than a certain number of attempts, we could do that 2 ways. We could take 1 minus the probability it's going to take more than that. Okay, so if I wanted to do what's the probability that x is going to be less than n, that's going to be 1 minus the probability that, all right, so let's think about it. If n were 4, I want to know what's the probability it's going to take less than 4 attempts. So it's going to be a success on the first attempt, the second attempt, or the third attempt. If it's on the 4th attempt, what would it be here? Would it be in this 4th? Nope. So usually we might do less than or equal to, like that's going to take 4 or less, and that's going to be the same as 1 minus the probability that x is going to be greater than n. So what we just calculated up here, we can use that to find the probability it's going to take less than or equal to. Okay. And where's my goodbye?